Hello all. So in this session we'll discuss about the pinout diagram of 8051 microcontroller. So as you can see, 8051 microcontroller is a 40 pin IC, 40 pin dual inline package. So out of 40 pins, we all know that 8051 has 4 ports. So port 1, port 0, port 2 and port 3. So if you observe, out of 40 pins, 32 pins are allotted as the port pins for the input output ports, and rest are reset. We have 2 pins, crystal 2 and crystal 1, between which we connect the crystal, ground, VCC, power supply, external access, oblique, VPP, ALE oblique, program bar and PSEN, program status enable pins. So let's see the description of each and every pin in detail. So first let's go with the pin number 18 and 19, which are crystal 1 and crystal 2. So let me write crystal. So between these 2 pins we connect the crystal. Now why do we require a clock? So the answer is the clock pulse triggers the operation of 8051. Higher the frequency, faster is the processor. Though the 8051 microcontroller belongs to the same era of 8086, it comes with a much higher clock frequency, 12 MHz. Because most of the operations are internal, and always internal operations are faster than external operations. And then we go with the pin number 9, reset pin. It is an active high pin. If the reset pin is high for a minimum of 2 machine cycles, the microcontroller will be reset. So when we reset the system, it is like the power is withdrawn and given back. So whatever is volatile will lose its data, that is nothing but the RAM, and programs will remain. And whenever the microcontroller is reset, it executes the BIOS programs, basic input output programs. For example, when we reset the mobile, what happens? It will not work immediately. It takes some 20 to 40 seconds because it is executing the BIOS program, meaning loading operating system, so that the whole system is ready for you to interact. And then pin number 30, ALE oblique program bar. So ALE, address latch enable, very important pin, address latch enable. So we know that here 8051 has got 16 address lines, A0 to A15, and out of 16 address lines, the lower order address bus is multiplexed with the data lines, so which are nothing but AD0 to AD7, and if you see the higher order A8 to A15. Now when you see these lines AD0 to AD7, they carry both address information as well as the data information. So whenever ALE is equal to 1, it is address, and whenever it is equal to 0, it is data. So usually it is used to demultiplex the address and data signals of the port. And coming to the other function, program bar. So this is used during the flash programming. This pin acts as a program pulse input. And next, pin number 31, external access. So as the name indicates, external access. So we have two cases when EA bar is equal to 0 and EA bar is equal to 1. When external access bar is equal to 0, then it is like we are discarding the internal ROM. Means we are not using the internal ROM at all. And the external ROM, the address range starts from 0000. So in this case we will be using only the external ROM, discarding the internal ROM. And when EA bar is equal to 1, internal ROM, we use the internal ROM, and first it starts from, because it is a 4 KB, internal ROM size is 4 KB. So it starts from 0000 to address range 0FFF. And then after that we give the address range for the external ROM. It starts from 1000 to maximum FFFF and VPP. So during flash programming, this pin receives a 12 volts program enable voltage. So it is used during the flash programming. Next, pin number 32 to 39. So these pins are known as port 0. So we all know that we can also access the every bit of port 0 individually by programming bit operations like set, clear, complement, etc. So port 0 is a dual function port. One is like it can be used as an input output port, and the other function is it is used as an lower order multiplexed address data bus. So next, going with the pin number 1 to 8. So pin number 1 to 8 are for the port 1. So unlike the port 0, port 1 doesn't has the dual functions. It is used only as a bidirectional IO port. And next, pin number 10 to 17. So these are the port 3 pins. So if you see, one of the function is using them as an input output port, and other it has got a alternate functions. Port 3 has the alternate functions. One serial port, so it is a bidirectional port. So we have the TXT and RXT lines to transmit the data and receive the data. So we know that interrupts, there are two external interrupts, INT0 and INT1. So two lines of it are dedicated to the interrupts. Timer 0. So the clock to be given to the timers T0 to T1 is fed from here. And read and write are active low strobe signals for read and write operations respectively. Then pin number 21 to 28. These pins are known as port 2, and it serves as an input output port. So as I already told you, port 2 has two functions. One is as an input output port, and the other function is from A8 to A15. It is used to carry the higher order address bus. Pin number 20 and 40 are VCC ground. Usually VCC plus 5 volts and ground is at the 0 volts. And pin number 29, this is PSEN, program status enable. Very important. It is used as a read signal. It is used as a read signal for the external program memory. For internal program memory, the read and write bar are used. And for the external program memory, that is for your external ROM, PSEN. So ROM means only we read the information, we don't write into it. So PSEN, program status enable, is used as a read signal for the external ROM memory. So with this we finish the pinout diagram description of 8051 microcontroller. Thank you.